Right, so the first question you are given the integral of square root x over 1 minus x dx. Lower limit 0, upper limit half. Then x is equals to sine squared theta is your substitution. The first thing to do is to make dx the subject of the formula by finding the derivative of x with respect to theta using the following equation or substitution. Right, so the first thing to know is sine squared theta is good as 1 dot product sine squared theta like this. I have placed 1 for a reason which I'm going to explain. Right, so when calculating the derivative of a trig function where a trig function has got a power, you have to multiply this power with the constant term attached to the trig ratio. So 2 times 1, you get 2. Then you less 2 by 1. So this is 2 minus 1 theta. But you have to multiply by the derivative of sine theta, ignoring the constant term in the power. So the power 2 multiplies the constant, you get 2. Then you less the power by 1. So this is 2 minus 1. But after doing the power rule, you have to multiply by the derivative of sine theta, ignoring this 1 and this power 2. I hope you are listening, class. Right, so dx d theta is equals to 2 sine, remember 2 minus 1, you get 1. So you'll be left with sine theta, 2 sine theta. Then derivative of sine theta is cos theta. So I'm going to attach 2 sine theta with cos theta, which is the derivative of the trig sine theta. Right, so in order to make dx the subject of the formula, I need to multiply both sides by d theta or cross multiply by d theta. Right, so dx is equals to 2 sine theta cos theta d theta. Why? Because I have multiplied both sides by d theta. So d theta and d theta, they cancel each other on the left side. Then 2 sine theta cos theta times d theta, you get 2 sine theta cos theta d theta. So this is the first stage. Right, we are now moving on to stage 2. Stage 2 is the change of limits. You have to change the limits of x to the limits of theta. Right, so let me prepare a table like this. So let me put x on the left and theta on the right. So the upper limit for the integral is half and the lower limit is 0. So I need to find the value of theta when x is equal to half. This can be achieved using the given substitution, which was x is equal to sine squared theta. Right, so I'm going to put half on x like this. You get half is equal to sine squared theta. To make theta the subject of the formula, you start by creating or introducing a root sign both sides. So square root of 1 is 1, square root of 2, you get root 2, is equals to square root of sine squared theta, you get sine theta. So it means that to make theta the subject, you have to introduce arc sine on your right side like this. So arc sine of 1 over root 2, you get pi over 4. So it means that pi over 4 is the one which is representing the value of theta when x is equal to half. So I'm going to write pi over 4 as the new limit. Right. Then we move on to the next. We want to find the value of theta when x is 0. So utilizing the same equation, x is equal to sine squared theta, you put 0 on x like this. So it's sine squared theta square root. You get 0 is equal to sine theta. You put arc sine of 0, you get 0. Right, so it means that 0 is going to remain 0. Since arc sine of 0, it gives you 0. So when x is 0, it means that theta is 0. So this is how you do in order to change your limits. We are now moving on to stage 3. Right, we are now moving on to stage 3. In this stage, we'll be doing the substitution process. Right, so the first thing, I'm going to write my integral. Remember, the upper limit, which is half, has been changed to pi over 4. Right, pi over 4 is the value of theta when x is equal to half. Then 0 remains 0. So you first of all substitute the new limits, right, of theta, right. Then I'm going to write the square root like this, right. Remember, x is being represented by sine squared theta. So on x, I'm going to write sine squared theta on x like this. Then 1 minus, remove this x, you write sine squared theta. Right, then you have to multiply by dx. But remember, in the first stage, we made dx the subject of the formula. So it means dx is being represented by 2 sine theta cos theta d theta. So I'm going to write 2 sine theta cos theta d theta representing dx. Right, then 1 minus sine squared theta is good as cos squared theta. Taking it from this identity, sine squared theta plus cos squared theta is identical to 1. So making cos squared theta the subject of the formula, you move sine squared theta on your right side, giving you cos squared theta is identical to 1 minus sine squared theta. So on this sine squared theta, I'm going to represent this sine squared theta by cos squared theta using that identity. I hope you are following, class. Right. So it is going to give me pi over 4, 0. Then I create my root sign like this. We have got sine squared theta over cos squared theta representing 1 minus sine squared theta times the dx, which is 2 sine theta cos theta d theta. Right. So we proceed. Pi over 4 is our upper limit and 4 is our lower limit. Square root of sine squared theta, you get sine theta. Square root of cos squared theta, you get cos theta. Then you have to multiply by 2 sine theta cos theta d theta. I hope you are following, class. Right. So cos theta and cos theta, they cancel out each other. Then you will be left out with integral of pi over 4, 0. Then sine theta times 2 sine theta, you get 2 sine squared theta d theta. Right, so we need to integrate 2 sine squared theta d theta. I hope you are listening, class. Right, so when integrating a trig ratio, make sure that the trig ratio takes one of those 3 forms in this box. Right, make sure the trig is a sine without a power. Make sure the trig is a cos without a power, or the trig is sec squared x right? So if you look at our trig, we have sine squared theta. So a sine with a power cannot be integrated directly. Hence, we need to make use of trig identities so that this sine squared theta takes form of one of those three forms in this box, right? Like integral of sine x, you get minus cos x plus c. Integral of cos x, you get sine x plus c. Integral of sec squared x, you get tan x plus c, right? So, the first thing to do, I want you to take note of this troubleshooter. Sine squared theta is identical to half, open bracket, 1 minus cos 2 theta. So you need to take note of this identity. That sine squared theta is identical to half minus half, open bracket, 1 minus cos 2 theta, right? So it was generated from the double angle identity of cos 2 theta. Remember, cos 2 theta is good as cos squared theta minus sine squared theta, right? But it can also be written as 2 cos squared theta minus 1, or it can be written as 1 minus 2 sine squared theta. So this cos 2 theta can be written in three forms, right? So if you take this form and cos 2 theta and make sine squared theta the subject of the formula. Take, for example, you have cos 2 theta, right, is identical to 1 minus 2 sine squared theta. So the first thing, you move 2 sine squared theta to your left side. You get 2 sine squared theta. Then you will be left out with 1 on your right side. Then you move cos 2 theta to your right side. It gives you minus cos 2 theta. Then to make sine squared theta the subject, you have to divide by 2 both sides, or to multiply both sides by half. So if I multiply both sides by half, two and 2, they cancel out each other, giving you this identity, which is half, open bracket, 1 minus cos 2 theta, which I want you to take note of, so that when you are in an exam situation, you don't have to do the whole process to make sine squared theta the subject, but you have to memorize that sine squared theta can be written as half minus cos 2 theta, right? So I'm going to substitute this half minus half, open bracket, 1 minus cos 2 theta on sine squared theta. So we have pi over 4 and 0, 2, right, half 1 minus cos 2 theta, close bracket, d theta. Right, so these 2 and this 2, they cancel out each other. So pi over 4, upper limit, 0. You will be left out with the 1 minus cos 2 theta d theta inside the integral. Right, I hope you are listening, class. So why have I used this trig identity? Remember, the goal is to put the trig function in one of the 3 forms inside the box. So we now have cos 2 theta without a power, which takes the middle form. It is now possible to integrate directly. Right, so I'm going to put a big bracket. We have upper limit pi over 4, lower limit 0. Integral of 1 is theta, right? Then integral of cos. Remember, I have given you that integral of cos x, you get sine x, right? So integral of cos 2 theta, you start by writing sine 2 theta. but you have to divide by the derivative of 2 theta, which is 2. Then you close your bracket, right? So we now need to identify the difference between the substitution of the upper limit minus the substitution of the lower limit. So in this first big bracket, you have to substitute theta by pi over 4. And in this second big bracket, you have to substitute theta by 0. So placing pi over 4 here, you get pi over 4 minus sine, right? Open bracket 2. Remember, this is 2 theta, so it's 2 times pi over 4 divided by 2. Then you put 0. We are now substituting the lower limit on the same expression. You get 0. Then if you put 0 on 2 theta, it gives you sine 0 divided by 2. Right. We move on to the next stage. We now have pi over 4, right? Minus. So 2 times pi over 4, it gives you pi over 2 divided by 2. Right. Then sine 0 is 0. So the whole bracket is going to become 0. Right. But do not take it for granted, because sometimes you can see or you can come across a situation whereby you have cos 0 divided by 2. So do not take it for granted that just because there is a 0, everything is going to become 0, right? Cos 0 is not 0. So if you have cos 0 over 2, it gives you half 1 over 2, right? So sine 0 is 0. 0 over 2, you get 0, right? But do not take it for granted that whenever you see 0, everything is going to become 0. Because cos 0 is not 0. Cos 0, it gives you 1. I hope you are listening, class. Right. So, pi over 4 minus, so sine pi over 2 is 1. You can punch it in your calculator, but make sure when using your calculator, it is in radians, not in degree mode, but it is in radians. Whenever you do integration by substitution involving trig ratios, make sure your calculator is in radians. So sine pi over 2, it gives you 1 over 2, and this is your final answer. So this is how you integrate this type of a question.